In this video, we're going to review graphing different forms of linear equations. We're asked to identify the form of each linear equation given, and then sketch the graph of each line. For this first equation, we're given that y equals 7/4 x minus 5. So the first thing that we want to do is identify that that form is the slope-intercept form. And that form has slope and intercept, and the key is that it's y equals mx plus b, which I'm going to write above our equation here. And so we can identify both the slope and the y-intercept just from the equation. We can read it out of the form of the equation. So the slope is going to be that coefficient on x, which is 7/4. So we have that m equals 7/4. And we'll remember that that's rise over run, which we'll use when we graph this line. The y-intercept is going to have an x value. It'll be a point, and it'll have an x value of 0. And then we can identify the y value out of that equation. Because we have 7/4 x minus 5, we identify that the value of b is negative 5. So the y-intercept is then the point 0, negative 5. So with these two pieces of information, we'll graph this line. So one of the things we want to do to start, we'll label our axes with x and y, and we'll give them a scale. Looking at, I need to graph 0, negative 5, and it'll have a slope of 7/4. I'll look at this 8x8 grid and just give every tick mark 1 unit. So I'll mark off 4 and 8 on each the x and y axis, and then I'll mark off negative 4 and negative 8. Okay, so now I want to put this key information in. I'll graph the point 0, negative 5, and then I'll use the slope, which is 7/4, to find other points on that line. So slope of 7/4, if I'm thinking rise over run, I have positive 7, positive 4, so I'm going to go up 7 units and right 4 units. So I've just counted those out on the lines, and I've marked off some dots, and I'll have the point 4, 2 now. So I don't want to keep these other dots, those were just for counting off, so I'll make sure that those disappear. Okay, now to graph this line, I'm going to connect these 2 points. So I'll grab my ruler, and I'll line it up so that it goes between these 2. Okay, so I have that lined up, and I'll draw a line now through those 2 points, and I'll move my ruler out of the way. I'll add arrows on the end showing that it continues in both directions, and now I have the graph of my line. The second equation that we're given is y equals negative 3 times the quantity of x minus 2 plus 1. So for this one, the first thing we want to note is that this is in point slope form. So that's the form that's given. And the general form, which I'll write right above our equation, is y equals m times the quantity of x minus x1 plus y1. And remember here that x1 and y1 are denoting the x and y coordinates of one specific point. M is our slope, and then x and y are our variables. So for the point slope form, we can identify both one point on that line and the slope. So let's start with the slope. That's our value of m, and that is negative 3. And in order to graph that, we'll write it as a ratio. So I'm going to write it as negative 3 over 1, and that is rise over run. A point on this line that we can identify right out of that equation is going to be the coordinates for that x1 and y1. So we see that we have x minus 2, and then we're adding 1 onto the end. So the point that we can identify out of there is going to be the point 2, 1. We have 2 subtracted from that x, we have 1 added onto the end. So just based on that form, we can identify that this line contains the point 2, 1. Okay, now that we have one point and the slope, we have enough information to graph this line. So let's label our axes, and again I'll scale them. I'm just going to make each tick mark worth 1 unit, so I'll mark off 4 and 8 on both those x and y axes, and then -4 and -8. So I'll start by plotting that point. So I'm going to plot the point 2, 1. And now we'll use the slope to find other points on this line. So the slope is -3, and then when we write that as a ratio, that's -3 over 1. So our rise over run will have -3 over +1. So we'll go down 3 units and then right 1 unit, which will give me the point 3, -2. And again, I marked off little dots just to track going down 3 units and over 1. Those aren't part of my line. Those were just counting, so I'll make sure those are erased. To find more points on this line, I will keep going down 3 and right 1 unit. I'll find another point. I find the point 4, -5. I'll go down 3 and right again, and I'll get the point 5, -8. I could, if I wanted to, I could go up 3, left 1, thinking of +3 over -1. I could get more points on this graph doing that, and I'd have the point 1, 4. I have plenty of points at this stage to graph this line, so I'm going to grab my ruler and connect them. Okay, so I've lined my ruler up to go through all of these points. Now I will connect them with a line. And then again, I will add arrows to the ends to show that this line continues on. We'll look at one more equation here. We have the equation 2x plus 3y equal to 12. So the first thing we want to do is identify this form. This equation is in standard form. And standard form has ax plus by equal to c, where a, b, and c are constants. So there's a couple options for graphing this one. We can't identify the information we need immediately. So one option is to rewrite that equation in slope-intercept form and then use our methods that we did for graphing an equation in slope-intercept form. Another one is to calculate the x-intercept and the y-intercept. And because x and y are both on the left side of the equation and a constant is on the other, it's pretty simple to solve for those. So let's do that just for practice since we've already done that slope-intercept form. So we'll find our x-intercept, and again, our x-intercept occurs where the value of y is 0. So we will set y to 0 and determine that x value. So we'll have 2x plus 3 times 0 equal to 12. So 2x is 12, and that means that x is 6. So the point that we graph will be 6, 0. X is 6, y is 0. To find the y-intercept, that's going to occur where x is 0. So we'll set x equal to 0 and solve for y. So we'll have 2 times 0 plus 3y equal to 12. That means that 3y is 12, and that makes y equal to 4. So that point that we graph will be 0, 4. Okay, we can find other points to get a third point. Generally 2 is enough. We can also, once we graph those two, use the slope to find a third point. So let's scale these axes, and I'm going to use my standard 8x8 grid. I'll label off 4 and 8 on the x and y axis, and -4 and -8 on those axes as well. Okay, so we'll plot these points. I'm going to plot the point 6, 0, and then I'll plot the point 0, 4. And now, if I wanted to, I could see that to get from this point 6, 0 to 0, 4, I go up 4 units, left 6. I could do that again and find the point -6, 8. Now we can grab our ruler and connect these with a straight line. So I have my ruler lined up, and I will connect those. And then I'll make sure and add arrows to each end to show that that line continues on. And that is a summary of 3 different types of linear equations and how we can graph each of them.